Good afternoon and welcome everybody to the Hydrogen and Fuel Cells Europe here at the Hannover Messe 2023. We're here at the technical forum where we dive into the juicy details of the hydrogen technology. Up next, we'll go into measurement of trace impurities in UHP hydrogen for fuel cells. We'll be talking about the ISO 14687, quite a mouthful. I'm here with Heinrich Meyer, sales manager from in Germany. Please come to the stage. Welcome.
Nice to meet you. Thank you very much for your kind introduction and welcome to all of you. What do I want to present within the next 15 minutes? First, I would like to present to you our company PST at a glance. Second, I will show you the ISO 14687, which specifies the quality of hydrogen for fuel cell vehicles. Third is about our complete and modular solution for the quality control of hydrogen according to ISO 14687. Fourth, I will present different measurement requirements depending on the manufacturing process of hydrogen. And finally, I will give a short summary. Process Sensing Technologies was founded 2016 in the UK. The goal was to create a new technical company by acquisitions, where the new group will be more than just the sum of the acquired companies because of synergistic effects. The first company that was acquired was Michel Instruments. Up to now, a total of 10 companies were acquired that you find here on the left side. All these former independent companies are now PST brands. Actually, PST has 8 R&D and manufacturing sites with 14 own measurement technologies, 22 sales and service offices, more than 800 employees, and more than 100 distributor and service partners globally. How does a hydrogen fuel cell generate electricity? In simple words, a fuel cell is an electrochemical cell where hydrogen and oxygen react to form water and thus generate electrical power. Unfortunately, actual fuel cells are still very sensitive to impurities like sulfur or carbon monoxide. These chemicals work like a catalyst poison and reduce the performance or even destroy the fuel cell. Therefore, hydrogen for fuel cells must always be very pure. The ISO 14687 shows the hydrogen quality requirements for PEM fuel cell vehicles. The hydrogen must have a minimum purity better than 99.97%. Many impurities must be controlled to be below these here listed ppm or ppb limits. Especially total sulfur with only 4 ppb is a big challenge, but also the ppb limits of carbon monoxide and the reactive chemicals at the bottom of this table are challenging. The right column shows many ASTM test methods, which are a broad mixture of different technologies and instruments. To clean this up and make hydrogen quality control easier, PST has developed an all-in-one solution based on its well-proven process GC LDTEC Multi-DTEC 3 with its core item, the plasma emission detector LDTEC Plasma DTEC. How does this plasma detector work? On the left side, we see the design of the plasma detector. Gas flows through a quartz tube, and a high-frequency voltage creates a plasma. The plasma emits light, which is specific for each impurity. To make this detector more selective, we add selective filters. Only the light of the impurity to be measured can pass this filter. All other light is blocked. The light is then collected by a photodiode, amplified and shown in a chromatogram. This slide shows the impact of a selective filter. On the left, we see a chromatogram of 5 ppm nitrogen in hydrogen without a selective filter. We see a big hydrogen peak and a small nitrogen peak on the hydrogen tail. On the right, we find the result using a selective filter. The hydrogen peak has totally been filtered out. Let us now look at the results for the very challenging sulfur measurement in hydrogen. This slide shows a chromatogram for 3 ppb H2S and COS in hydrogen each. With our selective PD system, we achieve low detection limits far below 1 ppb. We get the same result for the other sulfur components, like shown in this slide. Again, the low detection limits for all sulfur components are below 1 ppb. We can also install a thermal conductivity detector, TCD, in our Multi-DTEC 3. With that detector, we can measure the hydrogen purity by creating only one single peak for all impurities. For a range of 99 to 100% hydrogen, we achieve an accuracy of 0.001% with a total analysis time of only 60 seconds. Okay, that's enough with chromatograms for today, promised. Let us now have a look at and into our process GC Multi-DTEC 3. I do not want to go too deep into details, but it is a modern GC with touch screen at the front that can also be controlled remotely. Since the front door as well as the back and top cover can easily be opened, it is easy to service. On the right, we see a fully equipped GC. We can install up to 3 detectors and up to 6 ovens. This slide now shows how our solution, LDTEC HiDTEC, provides a full ISO 14687 measurement. The first GC is equipped with 2 PED detectors for the measurement of all reactive components. The third detector is a quartz crystal microbalance for the measurement of moisture. The second GC is equipped with 2 PED for the permanent gases and 1 TCD for helium. And the third GC as a TCD detector for the fast purity measurement of hydrogen in the range of 99 to 100%. This slide is to show that a full ISO 14687 quality control is not always needed. Actually, most of the hydrogen is still produced by methane or natural gas reforming. Natural gas always contains sulfur and many other impurities, and a full ISO measurement should be used for the quality control of this gray hydrogen. However, the increasing trend for manufacturing green hydrogen is water electrolysis. Here, sulfur should not be present and a reduced quality control measurement can be applied. On the other side, safety measurements play an even more important role to assure that hydrogen and oxygen do not create an explosive mixture. This slide gives a short overview about different solutions that we offer for hydrogen quality and safety control measurement. If a full ISO 14687 is needed, we can offer our HyDetect system. If individual impurities or a purity measurement of hydrogen is requested, we can equip our modular GC accordingly in non-X or EX version. For electrolyzer safety measurements like 0 to 5% hydrogen in oxygen as a range, or 0 to 5% oxygen in hydrogen on the other side, our XTC 601 or SIL02 can be used, both EX and SIL2 certified. Last but not least, if only a dew point measurement is needed, our quartz crystal analyzer QMA or ceramic transmitter EasyDew Pro IS can do this job very well. Let me now summarize the past minutes as a take-home message for you. First, hydrogen fuel cells are very sensitive to catalyst poisons and require very pure hydrogen. Second, ISO 14687 defines the quality specifications of hydrogen for PEM fuel cells. Third, with a HyDetect system, PST offers a complete and modular solution for ISO 14687 quality control of hydrogen. Fourth, depending on the manufacturing process, often a reduced measurement can be used. Fifth, for any further information, please visit our website, processsensing.com, or send me an email to heinrich.meyer@processsensing.com, or visit our booth number F28 in this hall, over there. Thank you very much for your attention.
Thank you very much for your presentation, Heinrich. I don't think we have any time for questions from the audience at the moment, but I have a question for you. What can we see at your booth?
We see our Process GC Multi-Detect 3 running at the booth. So I invite you, come to the booth, have a look, and even touch it if you want.
Great. Sounds like it's worth a visit. All right. Thank you.
Thank you very much.